All right, we're going to go over section 2.3. It's going to be a short section, a short video. It's reviewing how to graph lines in different forms. So a lot of this you're probably going to not even need a review on, but there's some certain pieces that I think you need to see, like standard form here and pulling information out of standard form so that we're not always putting things into slope-intercept. So make sure you're paying attention to that. All right, so looking at these notes here, slope-intercept form, I know you know what that is. We're going to put it here anyways. Y equals mx plus b. M is the slope. B is the y-intercept, and we're going to write down exactly what they are in a second here. The slope is, I know you guys have said things like rise over run before. I like to use the idea that slope is change in y over change in x. That little sign right there, I don't know where you want to write this. That is the Greek letter delta, and it stands for change. Okay, anytime you see that little triangle, it means change, and it's because it's the Greek letter delta, and that's what it's always used to represent. Now, the equation for slope is, since we're looking for the change in y, y2 minus, y1 over x2 minus x1, and really the order doesn't matter which point you call point 2, which point you call point 1, as long as you're going in the same direction of both the numerator and denominator. And of course, that's rise over run if you want to write that, or like I said, change in y over change in x, or vertical change compared to horizontal change. The y-intercept, obviously that is where it crosses the y-axis. We want to get used to representing the y-intercept as a point. So instead of just saying b is the y-intercept, it's 0, b. Another form of a line is called standard form. Standard form is written with the x and the y on the same side. And just to separate it from any other form, we usually use capital letters in writing that equation when we don't have numbers in it. So ax plus by equals c is standard form. What we're going to do on the right here, in that little space right there, is we're going to solve that equation for y. We're going to get y by itself. So the first thing we're going to do, I guess I'll just write the whole thing over again here. The first thing we're going to do is we're going to subtract that ax over. So we have by equals, I'm going to put that ax in front, minus ax plus c. And then we're going to divide by b. But to do that, I'm going to divide each term by b, or multiply each term by 1 over b. So I really only need to do that to the coefficient in this first one. I don't need to do it to x. So it's going to be negative a over b as our coefficient, x plus c over b. What we have here now is slope-intercept form. The reason why we did that is so that we can relate our standard form parameters, a, b, and c, to the information we get from slope-intercept form. Most importantly, that the slope, m, is the same thing as negative a divided by b. So if you have an equation that's in standard form, you don't need to solve it for y to find the slope. You can just take the opposite of a divided by b, and that'll be the slope of that line. The way that we're normally going to graph standard form is by finding the intercepts, both the x and the y-intercepts. And there's a really easy way to do that. To find the y-intercept, we can let x equals 0 because x equals 0 for any y-intercept. And to find the x-intercept, we can let y equal 0. And in each case, then we're going to solve the resulting equation. A couple things to know about standard form. We'll graph things like this using the intercepts if the numbers are nice, and you'll kind of see what I mean as we go here. We want to leave it in standard form if at all possible, and use the intercepts, not put it in the slope-intercept form because that's extra steps that we really don't need to do. And really, standard form should not have any common factors that you can divide out of it. If you can divide a factor out, you could do that first. For example, if you had something like 10x plus 2y equals 8. You can divide that whole thing by 2 and change that into your standard form equation right there. They're going to graph to be the same exact line. All right, so let's check out a few examples here. It says find the slope, the x-intercepts, and the y-intercepts of the following. Let's find the intercepts first here. So a couple ways you could do this. You could write something like here, I'm going to find the x-intercept. Here I'm going to find the y-intercept. This is how I have it on my notes key. And then what you're going to do when you find the x-intercept, you're going to put 0 in for y. Well, what that makes happen is the y term completely goes away, and we're just left with this equation, 5x equals 10. And then we'll solve that. We get x equals 2. That's our x-intercept. Now, another way you could represent this or show your work is by just making a table like this and putting a 0 in for x, a 0 in for y, and then solving those equations. So once you get this, you could just put a 2 right here. They're showing your y-intercept being 0, 2. So what I'm trying to say here is you don't have to show all of this stuff. I'm doing it because it's an example. You kind of pick and choose how you want to show this. Now remember, to find your y-intercept, we're going to put 0 in for x. I put this in the wrong spot, didn't I? I just realized that. Remember, we put 0 in for y to find this guy. X equals 2 should have gone right there. Now when I put 0 in for y, 0 for x, that 5x goes away. We're left with 2y equals 10. And we'll solve that. We get y equals 5. So when we put 0 in for x, we got a y value of 5. We have our x and our y-intercept right there. So those are our intercepts, and you could represent them as points as well, like 2, 0, 0, 5. All right, now to get the slope, we're going to do that negative a over b. Okay, so I'm going to make sure I can see what I have here. We have 5 is a and b is 2, so it'd be negative 5 over 2. That's our slope. So these are the 3 things we're looking for there. Okay, and I didn't really show, maybe because this is our first example, I'll write that we're doing negative a over b, which gives us negative 5 over 2. So those are the 3 things that we're looking for here. Okay. We did one there together. Why don't you pause the video and then try to do this one on your own, and then we'll see if we get the same thing. I'm just going to use a table here with this one, and just, well, it doesn't need to be that big, and just go 0 in for x, 0 in for y. Okay. When I put 0 in for x, I'm finding my y-intercept, and I put 0 in, I'm left with negative 5y equals 20, which would mean that y equals negative 4. When I put 0 in for y, I get 4x equals 20, which means that x equals 5. So our x and y intercepts are 5, 0. Order doesn't matter here. You can put them in any order you want. And then the y-intercept is 0, negative 4. And then the slope is going to be the opposite of a over b. So that'd be negative 4 over negative 5. Those negatives cancel out, and you're just left with 4/5 as your slope. All right, we're going to graph some equations down here. Some are in slope-intercept form, some are in standard. If you are good to go with slope-intercept form, you can fast forward through a few of these. This one here, and I don't even care if you write any notes down, or not notes, but work as you're graphing stuff like this. You have a y-intercept of negative 1, so I'm just going to go negative 1 and put a point. And our slope is 2/3, so we have a rise of 2 and a run of 3, so I'm going to go up 2 over 3. And I'm going to do that in both directions. I'm going to go down 2 and over 3. Okay, and you don't have to get so crazy with positives and negatives here. What you got to know is that this is a positive slope. So positive slope should be going up from left to right. So just make sure that it's going in the right direction after you get a few points. And we could even get a few more points here. It only takes a few seconds, just continuing that slope. And there's our line. Okay, so when we graph lines, it's kind of hard in this. I'm going to try to make it as straight as I can. We want to go through the entire graph as much as we can, and then we want to put arrows on the end to show that this line goes forever in both directions. In our next equation here, we have no y-intercept there, so that means that we're crossing through the origin. The y-intercept is 0. We have a slope of 2, so remember that means that the denominator is 1, so we're going up 2 over 1, and again it's positive, so I want to be going up 2 over 1 with a positive slope no matter which direction I go. And then we can graph this thing just like that. All right, in our next example, notice right away that the slope is negative, so we should be going down from left to right. Another thing to keep in mind too is that a slope of 1, so this isn't correct here, but I'm just using this graph. A slope of 1 is going right through those diagonals perfectly. It's a 45-degree angle. Anything that is greater than 1 will be steeper. Anything that is less than 1 will be a more gradual slope. So it's something to keep in mind here too. This is bigger than 1 even though it's negative. So I know it's negative, but I also know it's going to be steeper than that 45 degrees. So now let's go ahead and graph this. We got a y-intercept of 1, and we're going to go up 5 over 4, but I want to make sure I go in the negative direction here. So 1, 2, 3, 4 this way, and I'm going to go down 5, 1, 2, 3, 4, 5 over 4, 1, 2, 3, 4, and we're going negative. Got a negative slope, and like we said, it's a little bit more steep than it would be if it were a slope of just negative 1. In the next two problems here, we have just one variable, which means we're going to have either a horizontal or a vertical line. If you have a y equals equation, y equals 4 in this case says that every y value on this line will be 4. Well, here's a y value of 4. If every point on this line has a y value of 4, that means that this is a horizontal line. Now, you don't have to draw points. I'm just making a case here. But this is going to be a horizontal line going through 4 on the y-axis. Okay, so make sure you know that y equals some number is a horizontal line. Okay, I just remember whatever variable I see right there, if it's one variable, whatever variable it is, it goes through that value on that axis, perpendicular to that axis, straight through that axis. So we have x equals negative 3 here. It's going to go through negative 3 on the x-axis, but not like this. Okay, it's going to be going perpendicular to that axis so that every x value is 3. So if you have x equals a number, then you have a vertical line. Our last example is standard form. You've got ax plus by equals c. So let's do this first. Let's find the slope of this line first. The slope is negative a over b. So it would be negative 3 over 2, or negative 3 halves. So we already know that this thing's going to be doing something like that. And now let's find the x and y intercepts. I'm just going to put a 0 in for x and a 0 in for y. If I put a 0 in for x, I have 2y equals negative 12, which means that y equals negative 6. Let's go ahead and plot that right away. 0, negative 6. And if I put a 0 in for y, then the equation I have is 3x equals negative 12, which is negative 4. And the fact that I already found this slope kind of helps out. We knew it was negative. We can tell looking at these points that it's negative. Now let's use that slope to get a few more points. If I went down 3, 1, 2, 3, over 2, 1, 2. And if I did that one more time, you'd see I'd match up with that other point that I have, so that's a good thing. I'm going to go back up from here, 1, 2, 3, 1, 2, and just get one more point, just to make sure that everything is legit. And there's our line. So that's standard form. One thing that I didn't point out, because I usually just use the slope, but notice that you can also find the y-intercept by taking c divided by b. I don't use that a ton, but I think it's kind of neat to point out that that would work. If we took c divided by b here, if we wanted to find the y-intercept, we would take negative 12 divided by 2, which is negative 6. And look, that's already what we found there. But just to see that this stuff should all kind of work together, it should all match up. I don't use this very often because I do it right there. But like I said, it's kind of nice to see that everything works together. So that's 2.3. Different forms of lines, graphing them, getting some information from an equation, which is a really important thing in this class. 2.4 on the back side of this, we're going to do a separate video for. This is now going to be about writing equations of lines, whether it be using point slope form, slope intercept, and even in some cases standard as well. But that's going to be a separate video.